Hi, everyone. Welcome back. Today, we are going to be talking about sampling techniques. So, whenever we're doing some sort of study, right, some sort of study, we need to figure out who is the target population and also who is the sample. So, I want to go over those terms really quick. So, a population is the entire group that we want to draw conclusions about. So, for example, if I want to do a survey to find out what students at the University of Toronto think about the administrative staff, then that would be my target population would be students who attend the University of Toronto, right? If I would like to figure out how many people, what people in Canada think of the prime minister or the premier or, something like that, then my population is all of Canada. Or in the case of, provincial, like a premier, that would be maybe all of Ontario or all of whichever province we want to find out about, right? Maybe we want to know how healthy are teenagers, today, right? Then the population would be teenagers, perhaps teenagers in a specific region, because I'm sure the different regions are going to vary greatly in how healthy our teenagers are and what resources are available, all that kind of stuff. Okay, so the population is basically the group that we want to draw conclusions about, because oftentimes studies don't necessarily need to draw a conclusion about everybody overall. We want to know how can certain factors, influence the results we're going to get. Or sometimes we're just looking at a very specific population of people who live here, people who do this, people who go to this place, people who fill in the blank, right? So that's the population. A sample is the specific group that we actually collect data from, because odds are, if our target population is everybody in Canada, unless it's a census where they actually force you to participate, otherwise I think you have to pay a fine or something like that. you know you're not actually sampling everybody, and even with the census, some people are just going to suck it up and pay the fee and not even answer the census, right? Or in the case of, like, the school, probably not every single person is going to answer a survey or actually be part of that sample. It's probably only going to be a select group of students who are actually going to be participating, and so on. And so the sample is the specific group that we collect the data from. So we're not really getting an 100% accurate answer, and that can be for multiple reasons. But one reason is because we're just taking a sample. We're not actually drawing data from every single person in the population. Now we'll talk about ways to choose a good sample so that we can be confident that we're getting a pretty good idea. But you know, we're not going to get an 100% accurate conclusion when we're not sampling every single person who is in that group, right? Now, the sample size is always less than the total of the population, unless you're doing a census. Then, with a census, we're actually sampling everybody. But in general, when we're doing a sample versus population, our sample is going to be far less than the actual population. So let's talk about some different types of sampling, right? How do we actually choose which people we're going to sample versus which people we're not going to sample? So the first type of sampling is simple random sampling, where every member of the population has an equal chance of being chosen. So, for example, this could be drawing names out of a hat. I'm going to write some of these out because this is important. So please write this down. Drawing names out of a hat. Could also be computer generated, so the computer just randomly generates however many names. So computer randomly generates names, something like that. Or, we don't have to draw names from a hat necessarily. Could be a computer doing it, or could also be we're drawing names from a bucket or something. Doesn't have to be a hat. That's just an example. But yeah, basically every single person has an equal chance of being selected. We're just, randomly grabbing names and then those people are the people who actually get sampled. Awesome. All right. So an example of this is, let's say that the population is the school. So let's say U of T, And the sample is, let's say we choose, I don't know, let's say we choose 1,000 students who attend U of T, right? So maybe the principal just randomly puts all the students' names into like a generator for the computer, because writing down tens of thousands of students, and putting them in a hat's probably not the easiest task, but they probably have a list somewhere of all the students, and then just randomly select those 1,000 and then email them or figure out how we're going to actually sample them. Good. The next one is a systematic sample, and this sample is selected by listing a population sequentially and then choosing members at a regular interval. So, for example, for this one, let's say we have a list of all those students who attend, and we're going to sample every fifth student. So, we're going to sample student 5, student 10, student 15, student 20, etc. on this list until we reach the end of our list. The sample size and population size are going to depend on the sampling interval as well, right? So, for example, let's say that the population is actually, let's choose a different population this time. Let's say that it is the internet company. Let's say the population is the internet company customers, and that the sample could be we want to survey every 10th customer, right? For example, survey every 10th customer. In this case, our interval is 10, and the interval is determined by the population size over the sample size, right? Because if our population size is going to end up being 10 times more than the sample size at the end of the day, because we're not sampling everyone, we're sampling every 10th customer to figure out how much these customers are liking their service. So, or whatever it is they want to find out about their customers, but that's likely it. That's likely what they'd like to find out. All right, so the next one is a stratified sample. This is where the population includes groups of members who share a common characteristic or strata. The sample has the same proportion of members from each strata as the population does. So, for example, let's say it's employees at Google, and let's say they want to find out about gender equality in the workforce, and they want to make sure that men and women are being equally represented. They would take the proportion of males and the proportion of females and make sure that the proportions are the same. Now, that does not mean the numbers are the same, right? If there's more males in the workplace, then more males are going to be surveyed, right? Just as if there's more females in the workplace, more females are going to be surveyed. However, the proportions must be the same for both, so they're both equally represented in this group as they are in the overall population, right? In the overall employees at Google. So that's something a lot of people get tripped up on is they think, oh, that means we're taking an equal number, and no, that's not the case. We're taking, an equal proportion, right? Another example is let's say that they're asking students and teachers at a school about a number about something. It doesn't matter what it is, right? And they're going to do a stratified sample. If they were to choose the same number of teachers, if they surveyed 30 students, 30 teachers, well, the students are underrepresented because even though there's the same number of teachers and students, there's probably a lot less teachers at most schools than there are students, right? For every teacher who works at a school, there's probably, I don't know, 30 or, at least 20 or 30 students at that school as well. And so surveying an equal number won't do. You just have to survey an equal proportion, which doesn't always mean an equal number. So that's definitely something to keep in mind there with that one, because that's a mistake. That's a common mistake I see a lot of people making. The next one is a cluster sample. So a cluster sample is a sample that's there to save time and money. A sample is randomly selected from a randomly selected group. So sometimes all elements in the randomly selected group are included in the sample. And this is different from a stratified method, which randomly selects a sample from each group, right? They select a sample from each group. Here we're going to go ahead and randomly select a group and survey everybody in that group. So, for example, let's say the population is delivery drivers in Toronto, for example. And let's say the sample is we're going to survey all pizza drivers, right? Because pizza drivers are one group, right? They're one of the groups, so we're just going to survey all of them and not go ahead and survey, the other groups. Now, this can pose certain problems because the experience of pizza drivers may not necessarily represent the experience of delivery drivers who deliver for other restaurants or deliver for Uber Eats or Skip the Dishes or Instacart or however many other things like that there are out there nowadays. However, the main benefit, a benefit to this one, is that it does save time and money to only have to survey kind of one group and then generalizing it to the entire population. But of course, there are limitations to this method. I mean, as there are limitations to all of these methods, even the census, right? Even the census isn't perfect. It costs a lot of money. All right, so the next one is multi-stage sampling, and this is the sampling. It's selected using several levels of random sampling. Okay, so let's say that the population is students at WCI, right? And let's assume that every student at WCI has a homeroom, right? And let's say to figure out the sample, we randomly select let's say 10 homerooms, and then we sample 10 randomly chosen people from each, right? And so this is kind of like cluster sampling, except with cluster sampling, we would sample everybody from a specific cluster or from specific clusters. In this case, we're randomly selecting some clusters, and then we're randomly selecting some people from each cluster. So it's kind of, it's sort of a mix, so to speak, of clusters and of, stratified as well. So it's where we have different stages of sampling rather than just doing one stage and calling it good. Number 6 is voluntary response sampling. And actually, I should warn you that number 6 and 7 are not very good, not very accurate, in my opinion. But basically, voluntary response sampling is sampling individuals by inviting any number from the population to participate, and then the people who respond. So, for example, let's say that we have the population is all students at U of T, University of Toronto, and the sample is everybody who answers their email or their survey that was emailed to them, everyone who actually bothers to answer their survey. Now, this might not really reflect an accurate results because at the end of the day, there's some people who just don't care, right? And so you're going to get people who feel very strongly about the issue more than people who don't feel very strongly. So let's say the survey is about what you feel, how you feel about semesters at a certain school, or how you feel about, some new building that was just built at U of T. People who feel very strongly one way or another are more likely to respond. If I don't really care one way or the other, I'm probably not going to choose to respond to my email unless I'm getting something out of it, right? Whereas somebody who really, really is happy with this new building is going to certainly answer that survey, or at least be more likely to answer that survey. Or somebody who thinks it was a complete waste of money, that U of T is, screwing them over by making this building and is very upset about it, is more likely to answer that survey, right? So we probably don't get enough of the people in the middle who don't really care much about the building, who, didn't really change their experience much. We're going to get a lot more, messages from the other people, from the people who really care a lot one way or the other. All right, so the next one is convenient sampling. So this is a sample that is selected because it's very easily accessible. It's very easy to sample these people, right? So the sample might not be random, right? The sample is likely not random, so the results aren't very reliable. So let's say, for example, the population is people in a certain city, and I choose to only sample my closest friends, right? Because the thing is, it's a lot more convenient for me to just give my friends a survey and ask them what they think, as opposed to actually figuring out an accurate sample, an accurate representation of people in the entire city. And so this sample is quite silly, or it could be, just who are the first 10 people I see that day, for example, and let's just sample them. Right. And so it's not really, this isn't very reliable whatsoever. In fact, I would argue that to some degree it might even be worse than voluntary sampling because at least then it's not completely biased in terms of who you know or who you happen to see or things like that. Although that's up for debate for sure as to which one is worse. But bottom line is voluntary response sample and convenience sample are not very reliable, not very good ways of sampling. I still think it's good to go over them because they are still methods of sampling. However, when you are asked to do a project, some sort of research project, let's say you were to choose one of these types of sampling, I don't think that the boss accepting it as a good method of sampling that's accurate is going to is likely to happen, or that people reading the article who know what type of sampling you used are going to take it very seriously, right? So just keep that in mind that 6 and 7 are just not very good. Okay, so here's some questions here. They are asking us to match each sampling method used in the following situations. So the first one says, for a survey, a student stands outside the grocery store to ask people questions. Well, clearly this is a convenience sample, right? Because it's just whoever walks by that day, whoever is convenient for us to sample. It's not necessarily random, right? We might not be getting people who don't shop at that grocery store or who shop there different days, things like that. We're really not necessarily getting um, the entirety of the population, although not that they've mentioned what the population actually is here, but it's just whoever is convenient, whoever happens to walk by and is willing to answer our survey. Number 2, to complete an assignment, a student posts a survey on Twitter to collect data. Well, this is a voluntary response sample because this is a sample where anyone can just choose to participate if they wish, or some people who don't wish to do so don't have to do so. So this would be F, I would say. The next one says a golf course that has 400 players playing chose every fifth player. Okay, well, that's systematic sampling, right? Because they start in a random place and then they just, select every fifth person. So that's would be systematic sampling. Okay, the next one is 30 employees of a company of 350 employees are chosen at random. So that would be simple random sampling. Basically, we're just saying, okay, there's 350. We're going to randomly choose by pulling them out of a hat or doing a computer generator. We're just randomly going to choose 30, and those are the people who get surveyed and get their voices heard. Number 5 says a school in Toronto is used in a survey. Um, about education in Toronto. Okay, so basically they're taking one school in Toronto and surveying that school, those people who go to that school, and making a generalization about all schools in Toronto, right? So it looks like they're choosing one cluster and making an assumption about the population. So this would be D. This would be cluster sampling. Then number 6 says for a survey, 30 grade 9s, 30 grade 10s, 30 grade 11s, and 30 grade 12s are chosen. So in this case, this would be this would be stratified sampling because they're equally representing different parts of the school. Now, for it to be stratified, it doesn't necessarily have to be all the same number, but I would say at most high schools in general, probably there's around approximately an equal number of grade 9s, grades 10s, grade 11s, grade 12s. I know there's some exceptions to that. Some schools might mostly focus on grade 11s and 12s, while other schools might have more grade 9 and 10. But in general, I would say probably most schools have similar numbers of all of these. And so equally representing them in those kinds of cases does mean having the same number or similar numbers for each group. All right. Number seven says, I guess it's probably going to be E because it's our last one, but let's read it anyway. All the girls, the grade 12 girls who are over 6 feet tall, are chosen for a survey. Well, actually, that wouldn't be E then. I think they're expecting us to choose E here, multi stage sampling. But they're actually doing certain clusters of people who are at different heights and then choosing all of them for a survey, not just choosing some. So I'm going to say that this is actually more likely to be D, cluster sampling. They're saying we're going to choose all the grade 12 girls, so people from a specific group who are over 6 feet tall, this specific cluster, and they're going to do a survey. I guess, we could argue it might be multi stage sampling in the sense of we're choosing only grade 12s and also only people who are over 6 feet tall. So perhaps that's what they're getting at there. Good. All right. Well, that is everything for today. Next time we will talk about bias in surveys, right? So, and how we can try to avoid it as much as possible. We can't completely avoid bias in surveys, but we will do our best, and we'll talk about how to do that in the next class. Bye, everyone.